Welcome to the course on Computer Communications Networks. In this first module, we will lay the foundation by studying the essential building blocks that make computer networking possible. Our focus will be on network architectures, switching techniques, transmission media, channel access methods, and link control protocols. We will also look at how networks connect at different levels and how routing algorithms determine the paths that data takes. Understanding these core principles is vital because modern digital communication systems, from the internet to mobile networks, are built on these fundamental concepts. 1.1 Network architectures. A network architecture is the structured framework that defines how communication in a network is organized. It specifies how different components such as computers, routers, switches, and transmission media interact. Two widely recognized models dominate networking education. The OSI reference model, a conceptual 7-layer framework that defines functions from physical transmission up to application-level interactions. The TCP/IP model, a more practical 4-layer framework widely used in real-world networks, consisting of the link layer, the internet layer, the transport layer, and the application layer. Network architectures help us standardize communication so that hardware and software from different vendors can interoperate. 1.2 Switching techniques. Switching is the process of moving data across a network. There are three primary switching methods. Circuit switching, used traditionally in telephone networks, where a dedicated path is established between two endpoints for the duration of the session. It provides predictable performance but wastes resources if the connection is idle. Packet switching, used in modern data networks, where information is divided into small packets that travel independently across the network. This method is efficient and resilient. Message switching, a less common method where entire messages are stored and forwarded at intermediate nodes, often causing delays. The Internet is based primarily on packet switching, as it balances efficiency with scalability. 1.3 Transmission media. The physical medium through which data travels plays a crucial role in network performance. Transmission media can be broadly categorized into guided and unguided. Guided media include twisted pair cables, coaxial cables, and optical fiber. Twisted pair cables are common in local area networks. Coaxial cables were widely used in older systems. Optical fiber provides extremely high bandwidth and long-distance communication. Unguided media refer to wireless communication through radio waves, microwaves, and infrared. Wireless systems offer flexibility but are subject to interference and attenuation. Each medium has characteristics such as bandwidth, attenuation, susceptibility to noise, and cost. Engineers select media based on application requirements, distance, and budget. 1.4 Channel access protocols. When multiple devices share the same medium, a method is needed to control how they access the channel. Channel access protocols determine how efficiently the medium is used. Examples include random access protocols, such as Aloha and Carrier Sense Multiple Access, CSMA, where devices transmit at but use rules to avoid or resolve collisions. Controlled access protocols, such as polling and token passing, where devices take turns or receive permission before transmitting. Channelization protocols, such as frequency division multiple access, FDMA, time division multiple access, TDMA, and code division multiple access, CDMA. These divide the channel into separate portions so multiple users can communicate simultaneously. The efficiency of each protocol depends on factors like traffic load, delay tolerance, and error rates. 1.5 Link control protocols. At the data link layer, link control protocols provide reliable communication over a physical link. They manage error detection, error correction, and flow control. Examples include stop and wait protocols, which send one frame at a time and wait for acknowledgement. Sliding window protocols, which allow multiple frames in transit, improving efficiency on long-distance links. Point-to-point protocol, PPP, used for direct connections between two network nodes. Efficiency in link control protocols comes from balancing overhead with reliability, ensuring minimal retransmissions while maximizing throughput. 1.6 Routing algorithms and protocols. Routing is the process of selecting a path for data to travel from source to destination across a network. There are two broad categories of routing algorithms. Distance vector algorithms, where each router shares information about the distance to other nodes with its neighbors. A classic example is the Routing Information Protocol, RIP. Link state algorithms, where routers have a complete map of the network and compute the shortest path. The Open Shortest Path First Protocol, or OSPF, is widely used here. Routing must balance efficiency, reliability, and adaptability. Advanced protocols such as Border Gateway Protocol, or BGP, govern routing between large networks, making global internet communication possible. 1.7 Interconnection at the link and network levels. Networks are often interconnected at multiple layers. At the link level, devices like switches and bridges connect multiple local networks. These operate mostly within a single broadcast domain. At the network level, routers interconnect different networks and manage traffic between them, often using the Internet Protocol as the standard addressing scheme. This layered interconnection ensures scalability and allows networks of different types to work together seamlessly. In this module, we examine the foundational aspects of computer communications networks, architectures, switching techniques, transmission media, channel access methods, link control protocols, routing algorithms, and interconnection at both link and network levels. These concepts form the bedrock of networking. In Module 2, we will explore higher-level protocols, including the Internet Protocol Suite, end-to-end protocols like TCP and UDP, congestion and flow control mechanisms, application-level protocols, and an introduction to network calculus.